My name is Peter Borah, and as Ryan said, I'm currently the lead Ethereum developer at Ownage, and we're building a platform for handling digital game content on the blockchain. I'm a developer, I'm a programmer, and I've been working full-time in the Ethereum space for the past 2 years or so. I was lucky enough to be one of, as far as I know, one of the first people to get paid to build things on top of Ethereum. And so the purpose of my talk today is to discuss the blockchain, and specifically the Ethereum blockchain, as a technological tool. We're all here because we've heard of the blockchain. We think it's something that could potentially be useful for us, useful for the world. And in order to actually make use of the blockchain as a tool, we need to know what the tool is actually good for. I'm sure you've all heard the saying that when all you have is a hammer, everything looks like a nail. And I think in the blockchain space, we're in an even worse situation because we've just invented the hammer. We're still not quite sure what a nail looks like. And so the purpose of my talk today is to try to give you a sense. I know that most people here aren't technical, so the goal is to give you, as business people, as government officials, as whatever you are, enough of a handle on the blockchain to start to make strategic decisions about it and to be able to really understand why we might use this tool, what it actually is for. So first, in order to do that, I want to give you my personal favorite definition of what a blockchain is. You've already heard a couple. I'm sure you'll hear more today. But looking at things from multiple angles is useful. And I think it's going to help us structure the rest of the talk. So my definition of a blockchain is that a blockchain is a distributed database which is so robust that it can be made public, which, from a technologist perspective, is actually a pretty powerful claim. Databases traditionally are the sort of thing that you keep locked in a vault deep and keep everyone away from as much as possible. We hear all the time about companies who have their databases hacked, and this is a disastrous situation for companies. And so having a database that's intended to be public, that's robust enough that it can survive being public on the internet, is a really powerful and interesting thing. And actually, in the case of Ethereum, we have a slightly more powerful thing, which is not just a distributed database, but it's a distributed computing platform, which is so robust that it can be made public. So the rest of this talk will be devoted to exploring what the implications of this fact are. I'm going to start actually with some of the negative implications. So the nature of a tool is that it's going to be good for some things and not good for other things. And in order to get this unique property that a blockchain is the sort of database that's so robust it can be made public, it's had to sacrifice some things that you would otherwise expect a database to be good at. So some of the things that blockchains sacrifice in order to get this property is speed. So blockchains are, at the moment, not very fast. Currently, the Ethereum block time is about 15 seconds, which means that when you add some information to the Ethereum database, it takes about 15 seconds on average for that information to actually get reflected, which, if this were a normal database, would not be particularly good. It sacrifices processing power. Vitalik, the inventor of Ethereum, has suggested that you think of the Ethereum network as a cell phone from the year 2000. That should give you a sense of what level of processing power we're talking about. Sacrifices some storage capacity. So right now, on the current version of the Ethereum blockchain, it costs somewhere on the order of 1 to 2 cents a kilobyte to store information, which you compare to something like Amazon Web Services, which costs about 4 cents for a gigabyte. We're talking 500,000 times more expensive to store information on the Ethereum blockchain. And finally, it sacrifices privacy. And this one tends to surprise people, but I don't think it should, because the nature of a blockchain is that it's a database that's so robust it can be made public. And so in order to, by the nature of that, it's not going to have the same privacy guarantees you would expect from a normal database. So a few caveats about this. First of all, there's active research being done on all of these drawbacks, and so 10, 20 years ago, this slide might look outdated, and we might be running everything on blockchains. But I'm interested in the short and medium term as well as the long term. And in the short and medium term, these are things that we're going to have to be thinking about as what a blockchain is actually for. The other caveat is that this doesn't mean that if your program, if your project requires speed or requires privacy, that you can't use a blockchain. There are, as we saw in the previous talk, a good solution to any problem is going to involve multiple technologies working in concert. So it's still entirely possible to build blockchain-based applications that have these good properties. but you're going to need to think about the relationship between the blockchain and other technologies in order to make sure that you're getting these properties, and the blockchain's not going to solve them for you. So with that out of the way, what do we want to use the blockchain for? Why is it a valuable technology that we should build things on top of? And I spent actually a good deal of time trying to boil down what the sort of business implications, what the strategic implications of the blockchain's design are. And I think I've actually come up with a relatively good rule of thumb for what the strategic implications of a blockchain are. I'm not going to claim that this covers all cases, but I think a lot of what blockchains are good for is covered by this rule. So my rule of thumb is that a blockchain lets you securely define the rules of interaction for some data or resources. So we're going to go through a good number of examples here so we can work out what this really means. But basically the idea is that up to this point, databases are things that you keep locked in a vault. And the reason that that's the case is because whoever has access to the database has control of the information, has control of the resources that database controls. By making a database that's robust enough to be public, we now have the ability to let people interact with data, interact with resources, only according to set rules, and only in the ways that they ought to be able to. So let's go through some examples of that. So I'm going to kind of work my way up the complexity scale, starting with some of the simpler, more straightforward examples of what a blockchain might do, and getting up to, in levels of complexity. So the simplest sort of rules for interaction with data, rules for interaction with resources, is at the level of the single individual or a single organization. And the reason you might want to set rules for yourself, even as a single individual or a single organization, is so that you can publicly commit yourself to that. So a simple example of that would be a personal budget. Let's say that you find yourself spending way too much money on food, and you want to limit yourself to just a certain amount per day. This is something that the Ethereum blockchain is entirely capable of handling. You set up a smart contract that controls your food fund. You give it the rule that you're the only one allowed to withdraw money from it because you don't want other people taking your money. And you give it the additional rule that even you are only allowed to withdraw $20 per day. And the Ethereum network will enforce that rule for you. It will, the entire world will know that you've set this rule up, and it will make sure that it happens. Of course, in the real world, you're going to want to get access to that money if you really need it, so you give your spouse an override or something. But the point is that even as an individual, even dealing with your own resources as an individual, there still might be cases where you want to set rules for how you interact with that. A larger scale example would be the land registry idea that we've already talked about a little bit today. Honduras and the Republic of Georgia have both announced that they're looking into putting their land registries on the blockchain. And so why might a government want to do this? Why not just keep the land registry the normal way in a normal database? Well, one of the main reasons is to prevent corruption and prevent the appearance of corruption. If you have the land registry stored on the database, on a private database hidden in the depths of some government agency, then it becomes possible for a corrupt government official to go in and change things and get himself some beachfront property. If it's on the blockchain, then all of that information is public, and therefore any tampering with that information is also public. Additionally, you can set up rules for how even you, as the government agency who controls land, you can set up rules for how you're allowed to change the registry, which prevents you from being corrupt even if you wanted to be. And so even as a sort of individual agency, an individual person, it can be useful to set up rules for interacting with data or rules for interacting with resources. But the most interesting examples come when you have more than one, when you have a group of peers, for instance, that want to set up some rules for how they interact with each other. So again, to take a small scale example of this, a group of roommates. If you have, let's say that you live in an apartment with some people, and you have a shared pool for dealing with necessities. You all put in $20 a week to buy toilet paper and whatever else you need. So the low-tech way of doing this, of course, is that you put a jar in the kitchen and put the money in every week, and whoever needs to spend from it can go spend from it. And that works pretty well, but maybe you want more transparency into whether people are actually putting the money in, how the money's getting spent. Maybe you don't trust Bob not to get drunk and spend it all on beer. So you want something with a little more structure to it. So again, the Ethereum blockchain can handle this quite nicely. You pool the money in a contract on the Ethereum blockchain and set up rules for accessing that money. You list the people who are allowed to access it. You can set perhaps limits on how much they're allowed to withdraw per day. You can require that they're not allowed to withdraw money unless they've made their monthly contribution. Whatever it is, whatever rules you need to set up, the Ethereum blockchain can enforce them for you. And no one person has to be in charge of this. You can work together as a group of peers to set rules that all of you have to follow. If you, it can be more complex things. If you want to make large purchases, require a vote of all the roommates. That's something the Ethereum blockchain can easily help you do. So again, to move to like a larger scale example, imagine that you have a group of businesses in the downtown of a small town or city, and they want to encourage people to come shop at the local businesses rather than buying everything on Amazon. So what they do is they decide to set up a shared loyalty program, where if you spend money at any of the stores in this downtown, you get points per dollar spent, however it works, and then you get discounts at each of these stores as a reward for contributing to the local economy. So if you think about what it would take to actually run that sort of shared loyalty program, you have to make sure that every store in the network is able to know when new points have been issued to someone. They need to know when those points have been spent by someone. And this is actually not trivial, right? If you can imagine like you had a card or something that you wrote this stuff down on, but you're gonna have to make sure that you know who's actually allowed to issue the points, make sure that every store in the network learns about it when that happens. So instead what you can do is you can use the Ethereum blockchain for this. Set up a smart contract that represents how many loyalty points each customer has. You set up a series of rules for who's allowed to add points to that, each of the store owners. You can set up limitations on that if you want to limit them to a number of points they're allowed to issue over a period of time or in what circumstances. And when someone spends these points and you deduct them, then the Ethereum blockchain takes care of making sure that that information is reflected across each of the stores. And so this solves our problems of how to coordinate the system. Because you have this shared database, and because you have the ability to have the rules for interacting with that database defined, then you simply keep a list of who has how many points and set up the rules for who's allowed to change it. And it takes care of the rest of it for you. You can imagine moving from there and actually handling even more of this program on the blockchain, especially if purchasing is running through the blockchain, if we're in some future where cryptocurrency has taken over, or if we have some system for converting from normal money to cryptocurrency. You can imagine automatically applying the discounts to the purchases done through the system. You can imagine automatically deducting points as purchases happen, etc. So these are more complex examples of what you might use a blockchain for, is to allow a group of peers to collaborate without having to designate one of them as the one in charge of the collaboration. As you add the customers into the mix, you start to move into the next category, which is heterogeneous groups of actors. So in the previous two examples, we were talking about groups of peers who are collaborating with a shared set of rules. But in the real economy, of course, you have situations where there's complex interactions that are asymmetrical, where different people have different roles and different responsibilities. So an example of this might be a sharing economy thing, so like Airbnb. People want to rent out their houses to travelers. The travelers want to rent those houses. You have at least three different groups here. You've got the travelers, you've got the landlords, and then you have Airbnb themselves, who work as curators, who make sure that scammers are kicked off of the system. So again, this can all be handled quite easily on the Ethereum blockchain. You set up a contract that represents an offer to rent a house. It lists the dates that it's available. It lists the rate at which it's available. So that is what the landlords do. The travelers interact with that, book a certain period of time. They have to send their money in order to do it. And then, of course, you have Airbnb, who have the ability to cancel contracts that turn out to be fraudulent, etc. There's a company, Slack, that I think has already come up today, that actually thinks there's a fourth party involved, which is the physical infrastructure, the actual thing being rented. In theory, if you have all of this information on the blockchain, and you have a smart lock on the room being rented, then it can be aware of when the rental happens and can open for the person who's paid the correct amount of money. So there may be more than the three sets of actors here. There may be a fourth, which is the physical infrastructure. And that moves us into the last category, and I think the most important, which is full ecosystems. So I've been discussing this as if it were groups of named actors, right? We have, in the case of the roommates, we know who all of the roommates are. Even in the case of Airbnb, we know who all of the renters are, perhaps, or we know who all of the landlords are, perhaps we know who all the travelers are. We certainly have, set roles for each group. But in reality, on the public blockchain, because we have this shared database, we have the ability to sort of build exponentially on top of anything that gets built on it, because everything is by default interoperable. So if you imagine in the Airbnb scenario, another actor that could come on board is a cleaning service that wants to clean the apartments of landlords who rent out their houses. And if it's run on the blockchain, then this can all be done automatically. Landlords can set up a subscription service with a cleaner. They can, then when a rental is finished, the cleaning service automatically gets notified, money's deducted from the account of the landlord, and the process is all done automatically. And because we've built on a blockchain, this decentralized Airbnb, Slack or whoever it is, doesn't have to build that themselves. They don't have to make that part of their system. By putting it on a public blockchain and making it part of this public database, this interoperability, this ability to build an ecosystem comes for free. And it's a pretty complex ecosystem, right? You've got players of games. You've got the people who make the games, which is its whole own ecosystem of artists and developers and producers and everything else. You've got stores, online stores, which sell the games. And the relationships between all these entities is quite complex. You've got, each player is going to play many different games, probably shop at multiple stores. Games might be sold at multiple stores. So we think that, and there are certainly parts of this ecosystem that shouldn't be on the blockchain. Going back to the previous slide, the gameplay itself, if you're playing League of Legends and you cast a spell, you can't wait 15 seconds to see what the result is. So you can't run the gameplay through the blockchain. And similarly, you can't store the game on the blockchain. It's, a modern video game might be 30 gigabytes, and that's going to cost you millions of dollars to put on the Ethereum blockchain. But the parts of the gaming ecosystem that are about the relationships between the actors, the fact that a player has purchased the game from a developer, the fact that a developer has given a store the right to sell a game, we think that works quite well on a blockchain. Because if you have the blockchain be the source of truth as to who owns a game or who owns an object within the game, then you get this ecosystem property. You have the ability for a developer to easily work with any number of stores they want to sell their game without any extra complexity in having to get them to work together. The blockchain handles the coordination between all the different entities. And you get the ecosystem property that once you've put this information on the blockchain, other people can build on top of it. So for instance, let's say that you wanted, you're a game developer and you feel that people should have the right to resell games that they've bought online, even though they don't have a physical copy of the game anymore because we do everything digitally. You still feel that, it's the customer's right to sell a used copy of a game that they've bought. Or perhaps you've made a commercial calculation and you think that you'll sell more copies if people know they can get their money back after they're done playing it. So you, in order to enable this, all you have to do on the blockchain is add an additional extra, 3 lines of code saying that the owner of a license for a game has the right to transfer it to someone else. And that's all you have to do in order to enable that possibility. Because once you have that, then anyone who wants to can build on top of that the infrastructure for a site for selling the used games, for trading used games so that, you know, someone who has one game and wants another can trade that with another person. And it can all happen trustlessly and securely in this decentralized way that blockchains allow you to do. And just by flipping that switch, just by like adding that rule that the owners of the license are allowed to transfer it to other people, you've opened that entire space of possibility to whoever wants to build on top of it. And so I think perhaps the most interesting and important thing about blockchains is that you get the ecosystem by default. If you're using a public blockchain, you're part of this public database, which means that everyone else also has access to that public database, giving you the ability to build on top of each other's things and really get the sort of exponential growth that something like the internet has created. One quick example of how powerful this ecosystem property is. You're all very familiar with the idea of logging into a web page. Any site on the internet that has the concept of users and accounts has a login page. And each company that runs an internet business has had to solve these problems for themselves. They have to figure out how to store your password. They have to figure out what rules they're going to set for passwords. They have to figure out what they're going to do in the case of a lost password. They have to figure out, you know, if they're going to be customer service people to handle lost passwords, or if it's all going to be an automated system. If there's an automated system, they have to set up the automated system. And then you, as the consumer, are relying on them to solve those problems well. If they don't store your database securely, then you have no recourse. If they don't store your password securely, you have no recourse. If you want additional levels of security, you can't build that yourselves. You know, there are these good practices like two-factor authentication that lets you use another device as part of the authentication for an online service. If you want that as a consumer and the application hasn't built that in, you're out of luck. And if they have built it in, you can only use their implementation, which means if it's not good, you're out of luck. On the Ethereum blockchain, if you're using this public blockchain as the record for your application and for users, then you get the ability to not have to solve this yourself. Because it's this public database, anyone who wants to can build new and better patterns for authentication for security. And users can adopt those as they will. So if a user wants two-factor authentication for their account, they can set that up themselves, and that will apply to everything that happens on the Ethereum network. And so you, as the business owner, no longer have to figure out how you want authentication to work for your business. You don't have to solve the same problem you've solved every time you've built a website with an account. Instead, you build the part of the system that is your specific, the thing that your business is specifically good at, the part of the system that is actually, the core value of your business. And you let things like the authentication come from the ecosystem, come from security researchers, come from open source projects. So that's just one example of how powerful this ecosystem property is. And I think it's, in many ways, the most interesting part of the whole blockchain experiment is that by giving us this public database rather than a bunch of private databases hidden in each company, we have the ability to really turn it into this exponentially growing ecosystem. So that's essentially my talk. I hope I've given you some idea of what a blockchain might be good for. I don't know if we're going to do questions or not, but thank you all for coming and for listening to me talk.